I'm Tony Sklar with bnetTV. We're here at the LTE Summit in Singapore. I'm speaking with Mr. Mark Murphy. How are you today, sir?
I'm doing well, thank you.
Excellent. Listen, for our first-time customers, our first-time viewers, why don't you tell us a little bit about Ericsson's position within the LTE arena?
Well, Ericsson's position in the LTE arena is to take advantage of the broadband, the low latency, the high speeds, and the capacity, and the converged services around all of those capabilities and delivering it in an all-IP network.
So globally, you guys excellent have a fantastic position within the ecosystem, but in Asia in particular, do you just look at the other markets? How is the footprint here looking?
I apologize, I'm coming from the US, so I'm responsible for the US region. So the LTE footprint for the US is growing quite vastly lately over the last couple of years. A lot of the operators are rolling out all the LTE, so you got the big Metro PCS, AT&T, Verizon, et cetera, are all launching LTE throughout nationwide.
So why is it that all of a sudden, for the first time in a very long time, the U.S. seems to be on the top of the food chain that way?
Yeah, that's quite nice.
It is quite nice. So why is that, and where is Ericsson positioned within that?
The reason is that they're trying to grow the density and the economy of scale that LTE brings you, because it can cover a lot more subscribers and a lot more area with the lower spectrum, the 700 megahertz that we have. It gives a much more powerful, a lot more economical business in order to move to 4G as opposed to the traditional 3G that we have today. So they want to move and migrate to LTE as quickly as possible.
More speed means more applications at a faster pace. Tell me a little bit about what we're looking at here behind you.
So what we have here is I'm taking advantage of LTE in the sense that it's just the transport. LTE has a lot of characteristics that allow me to deliver these applications and services with a quality of service per app. And voice is becoming an app, video is an app, everything is more or less an app as far as the internet and the LTE network is concerned. So now that we can do that, LTE can then differentiate each of those dedicated bearers and grant a quality of service for each and every one of those uniquely.
And does that mean that we're moving from more of that consumer-based model into more of the machine-to-machine or vehicle-to-vehicle or a business sense that allows for faster economics?
Absolutely. The machine-to-machine is the fastest growing area that we have. And the fact that we use IMS with LTE complemented together grants a much more powerful API-driven model that an operator can then build services and applications for these machine-to-machines without having to invest a lot of client development, etc. You just turn on the equipment and have it registered to the network natively, and then you can control, manage, and regulate that equipment.
What are we talking about in terms of speeds?
Speed is dictated on the amount of spectrum the operator has. So depending on if they're a frequency division or a time division, etc. type of operator, at least in the US speaking, what we have is we're all frequency division, 10 megahertz up and down. One cell sector can have about 80 megabits per second total throughput down and about 35 megabits up. That's the maximum, that's shared. So each user will see somewhere between 5 to 12 down and 2 to 5 up.
And that's that is an increase of what compared to what we have today?
With the 3G networks, it's all relative in each region and how much spectrum they have. So it's very fragmented. So some have more spectrum than others. So I would say it's a magnitude faster. So you're going from a latency, which is the response time between you talking to me, of 60 milliseconds on the HSPA type of plus, which is 3G, to somewhere in the neighborhood of 15 to 20 milliseconds on the LTE network. And then on the bandwidth side, you go from depending on how many combined radio networks they have, it's very specialized in certain areas, but they can go about 20 megabits per second on the HSPA plus up to, like I said, the 80 megabits per second on the LTE. So
Mark, you're going to give us a little bit of a demonstration of what we're experiencing today or in the future?
I'm going to show you the things that are coming very, very shortly. The networks are being built and they're being enabled with this technology. It's just a matter of time before the operators have rolled out enough infrastructure and start building the services to funnel through this type of environment.
Okay, take it away.
All right, so what I have here is I have this interface that I cover several different scenarios. And the scenarios range from a video gallery showing you bandwidth and speeds to medical dispatch, security and surveillance, training and education, and field dispatchment or public safety. And then on the far right-hand side, the upper section is my machine-to-machine. So as we grow over the next 10 years, 50 billion devices will be floating around on these cellular networks in some fashion, and being able to manage and control those is a huge area to address and look into. And then I have a video wall that we'll go through, and I'll show as I go through some of the other demos to kind of keep the bandwidth, because right now we're flatlining. We don't have any bandwidth on here. And you see my latency is right now around the 15 to 20 millisecond, and that's round trip time. That's from my computer over the air and back. So that's really quick. Anything less than 50 milliseconds is classified as real time or immediate, and the human eye and ear can't differentiate that whole mouth out of sync problem that we're all familiar with on TV. So what I'm going to do is I'm going to quickly hop through a couple of these scenarios. This one first. This one reinforces what I was saying earlier about the user experience amount of bandwidth that you'll see on the network. So 5 to 12 megabit is about what you can get going downlink. So what I'm showing you here is I have 4 independent videos that I'm streaming simultaneously. I got a 512, a 1 meg, a 2 meg, and a 4 meg. And if you add those 3 together, that averages about 7.5, 8 megabits per second. And that's what's reflected in my bandwidth meter there on the right. And the reason I do that is to show people 512 is about what you can get on 3G today. So most of the smartphones, etc., stream about 300 to 400K tops. This is 512. Now I've stretched this video is encoded at 720p. That's 1280 pixels by 720 pixels, which is the low end of high definition. And I did that to show apples to apples. So this is 512. You can see with a lot of motion, it's very grainy and pixelated. Now if I double that, you look at 1 meg. 1 meg it's quite nice. It gets much, much cleaner. You still get some of that ghosting when there's a lot of movement. You'll see it here in a moment. Like if you notice the bunny, you'll see the hairs on the side that's not quite as pronounced. And then if you flip it to 2 meg, 2 meg is the sweet spot for 720p. This is what the broadcast media, etc., want to be able to transmit at 720p, is 2.5 megabits per second. And of course I can go to the 4, which is just even more advanced. You can see the hairs, a lot more of the grass, etc. But it's the quality measurement that we see is not as pronounced as going from 1 to 2 as it is from 2 to 4. So that's just a quick and dirty showing some of the bandwidth that we'll get. So if I pause that, let's pick another scenario here. Now this is taking a whole different type of spin. This is now targeting the communicative services that the network's going to be able to provide. So on the left here, I have my buddy list. Buddy list's been around forever, nothing new. We all have one to many of them. But the difference being here is that now this buddy list is native to the network. I turn my phone on or I turn my machine to machine on, it now registers to the network for itself. I don't have to launch a client, I don't have to sign into anything, it's just there. Then I have all my enablers along the top. Text messaging, instant messaging, voice, push to talk, video, whiteboarding, file sharing, ... This is an all IP network. All of these services will just simply grow as the network matures and more applications are being delivered. In this case, what I have is I'm a medical dispatch, and I'm responsible for a series or an area that I want to be able to manage. I'm a dispatch located in Dallas, Texas. That's my office there. So what I'm going to do is I'm going to grab my tablet. It's over here. All right, so now I'm going to show this medical scenario. Here's my nurse is online. The nurse publishes the capabilities the nurse tablet has: text messaging, instant messaging, voice, push to talk, video, whiteboarding, file sharing, etc., etc. So what I'm going to do now is I'm simply going to jump to where the nurse is. The nurse is 9,000 miles away from me, based out of Dallas, which is here in Singapore. So in Singapore, you see the nurse's location. I now have a series of patients that I'm going to monitor or watch. So I'm going to do the fun one here. So I have a patient here on Sentosa Island that has a foot injury, Mr. Lebowski. So maybe a bowling-related injury, but you never know. All right, so it's a sports-related injury. I have a patient, ankle injury, so I'm going to send, I can see my nurse is about 4 miles out. The doctor's quite a bit further. So I'm going to assign the nurse to go and tend aid to this particular patient. So I'm going to go here and just simply drag the nurse icon and assign it, and you'll see on the nurse's tablet that notification has been sent. So you need to go ahead and accept that. Just close that one. And hit tasks. I'll let you drive. There it is. And you can accept or reject, so we'll go ahead and accept it. And you'll see I get that acknowledgement on here. Now the next step could be fully automated, but I do it manually just to kind of show and illustrate what's going on. So what I did here is I just draw on the map and I create a geofence. So within the network, there's a cloud of services and enablers that all of these fit within, that one of them is a geospatial server. So I publish 1, 2, 3, 4, 5 points of start and a stop to this geospatial type of server. So any trigger and event that happens, in this case, the nurse hitting this is going to send a trigger to me. In this case, it's going to push all the patient information to the nurse's tablet en route. So if you go ahead and hit locate on the, hit locate and then quickly close this so you can see it driving around. So you see the nurse will be driving along. That's my little drive simulator. And as soon as that nurse triggered that area, you'll see that the bandwidth is sending all the patient records over to the nurse's tablet. I can go ahead and, if you want to be a doctor. So now I'm the nurse. I'm on site. You can see I'm next to the patient here. So now I'm on site and I need some help. Right. So I'm going to look to some aid to an online doctor. So I have my doctor just right around the corner here. So I select a doctor. I can see how I can communicate to the doctor. So I'm simply going to do a video call. So I send an invitation to a video call. So the doctor's going to accept. Session established. There's my doctor. All right. So I'm going to go ahead and stand over here like this so you see me. What's up, doc? I've always wanted to do that one. All right. So now I'm online with my doctor. The doctor can see and hear me. All right. So now what I'm going to do is I'm going to share my information. So I'm going to open up a whiteboard. So that's going to send him an invite. He's going to accept that. So now what I can do is I can take a photograph of the injury. I can change the color of my pen. All right, doctor, it seems that the patient's complaining about a lot of pain in this area. Do you have any suggestions?
My suggestion is compression bandage from here all the way down.
All right. And as you can see, I still have my video session going. So each one of these services is a unique application in itself. I could build the client to where it shows everything all at once, but this reinforces that each one of these can be its own quality of service, it can be its own type of app, and I can still keep them all going at the same time. All right, Doc, I think I'm going to put it on ice, elevate it, and we'll close this case. Thanks for your help. All right, so there's the doctor, so I'm going to close that down. Open up my task, do my paperwork, fill out the form, hit submit, and the report shows up as completed. So this is a very simple scenario that shows the capabilities and all of the enablements, the APIs, etc., that the network's going to be able to harness and deliver. And then in this case, I just did video, whiteboarding, and file sharing. I have several other scenarios that take advantage of all the others. But you'll find the fundamental communication building blocks are these things you see here. You can do almost everything you need to build based on these type of enablers.
More speed equals many, many, many more applications. So this is just sort of the tip of the iceberg conceptually on what can happen within such a robust network.
This is a transition period in the wireless industry to go to this all IP network, all IP infrastructure, and the amount of services and the amount of capabilities are just going to grow immensely with every new generation of this long-term evolution, this LTE growth.
And as that long-term evolution comes into fruition, what's the next step for more speed? Because it's like a hard drive, right? The larger the drive is, the more capacity you end up using.
Yeah, it's there's something I read that broadband is the crack of the 21st century, right? The more we have, the more we want.
Right.
So basically, from there we consume as much as we possibly can. So we all really enjoy our bandwidth and our high speeds, and just helps facilitate and gives us that capability. And from a business side, it allows you to grow and expand the possibilities on how and change business models and change business opportunities as well.
And again, Ericsson obviously is right there at the forefront of that evolution.
We're trying.
Excellent. Mark, thanks very much for taking the opportunity to speak with us here today. I hope we get a chance to see some future growth here in the future.
Thank you very much.
I've been speaking with Mark Murphy here at Ericsson at the Asia LTE Forum in Singapore. I am Tony Sklar with bnetTV.